Okay, number 16, we have Congress. Table shows the number R of U.S. representatives for Texas as a function of the time T in years since 1930. We're supposed to graph the function. Well, let's make sure we know what this means. 0 years since 1930. That would be 1930. So in 1930, there were 21 representatives from Texas. And then if we said, well, 10, what does that represent? It's not the year 10. Okay, there were not 21 senators in Texas in the year 10. There were no senators in the year 10 in Texas. It means 10 years since 1930. So in 1940, there were 21 senators. If we're going to graph the data, one of the first things we have to establish is what are we going to use for our scales. Now when I do this graph, I'm mainly focusing on my positive x values and positive y values since we don't have any negative values. We usually call them the x and y axis, but in this case I'm going to use t and r instead. So the number of representatives is our dependent variable because it depends on the year. So instead of y, which is usually our dependent variable, I'm going to call it r for the number of representatives. The number of representatives depends on, independent variable is usually our x, so we're going to call that t for time. And whenever we have a real world situation, we want to make sure we label things. We've got number of representatives on the r axis, and this would be years since 1930. Now we just have to plot the points. Notice your t values go from 0 to 70. Well, if I go by ones, I'm never going to fit this data on the graph. I want to use a scale where I can definitely get all the points on, and I also don't want to make a huge scale. If I said, well, I'm going to make each box 70, well, sure. Well, yeah, I could get everything in there, but imagine getting all of these different points between here and here, between 0 and 70. You can't even see anything. So let's try to spread it out as much as we can. Going from 0 to 70, let's see, I've got this much space. Maybe I'm going to go by fives. Okay, so I've got 5 years, there's 10, 15, there's 20, 25, 30, 35, 40. There'd be 50 years later, 60, and 70. So even though I only labeled every 10, I am going by fives on the t-axis. It doesn't mean I have to go by fives on the r-axis. Here I'm starting at 21. Notice I'm not close to 0, so this would be a great opportunity to use the heartbeat and skip a bunch of values since we skipped basically 0 through 20, and I'm going to start it at 20. Now I need to get it up to a max of 32. Can I go by 1? I should be able to fit by 1. So I'm going to go 21, there's 22, 3, there's 24, 5, 6, watch it not fit, 27, 28, 29, 30. We can be creative and imagine it's up there. 32 is up there somewhere. So we've got plotting points. 0, 21. 0, 21 is going to be right there. 10, 21. Over 10, up 21. 20, 22. Over 20, up 22. It's going to be right there. 30, 23. Over 30. There's 23 right there. 40, 24, over 40, there's 24 right there. 50, 27, 26, 27 is right there. So big spike that year. 60, 30, there's 60. Let's work our way up to 30, which is right there. And then 70, 32, over 70, up 32, there's 31. 32 is going to be right about there. So notice we don't have perfectly linear data. But for the most part, this is growing an upward trend. The more years go by, the more reps Texas has, and it's growing at a fairly linear pace.